Okay, so we talked about kind of giving an overview of atherosclerosis and coronary artery disease in the last video. Let's go through now and kind of break down each one of these steps so that you can understand kind of what's causing, what's behind each one of those steps. So we start off here with this, there's just this image of the coronary artery. So imagine that that's one of these arteries here. We took like a bisection or a section of it and kind of magnified it so that we can talk about what makes up the wall of the blood vessel. Again, this isn't necessarily something you're going to need to have memorized as an RN, or even necessarily for the NCLEX, but you will have to know it for a patho exam, if that's, or but again, just having that understanding of what makes up the blood vessel wall. You're going to use this in so many other units and so many other things that you're trying to understand. It's just good to have a basic understanding of, the underlying anatomy. And I know a lot of you took anatomy recently and you remember, but for those of you who don't, let's just go over it really, really quickly. Again, this here is the wall of the blood vessel. It's separated into kind of three main areas. The tunica intima, if you look here, what I like about that is that they're really easy to remember because you have intima, like inside, media, like middle, and externa, like external or outside, right? So that makes it a little bit easier to remember. When we're talking about the tunica intima, we're talking about these first two layers. The first layer here, which is the endothelium, or you can see each endothelial cell here, right? So and then right underneath that, you have that basement membrane, kind of right here. And that's just made up of kind of proteins and collagen and elastic fibers. The reason it's important to kind of keep an eye on that is that the collagen that will come into play again later. So just remembering that this basement membrane is right underneath the endothelial cells. And it does consist of, yes, elastic fibers, and proteins, but also collagen, okay? The next layer is this tunica media. Basically, the tunica media is made up pretty much entirely of smooth muscle cells. That's what each of these little doohickeys are. So this layer here is what's responsible for your vasodilation, vasoconstriction. It provides kind of the support for, like the body of the lumen, right? It's kind of what like the skeleton, I guess, of it. And then you have the very outside one, the tunica externa, and this is basically just a dense layer of connective tissue, and again, collagen. And like I said, that collagen will come into play later. We talked about when we talked about hypertension, we talked about we've talked a lot about endothelial cells. We talked about them in inflammation. We talked about them in hypertension, and how they have these baroreceptors and chemoreceptors, right, that can sense changes in blood pressure, changes in the amount of oxygen and blood flow that are going through that lumen, and then can send signals. We talked about how it sends a signal to the medulla and pons, and kicks in the SNS and so on. That's another video which you guys can review later if you want to. But the idea is that this endothelium kind of provides this smooth kind of inside layer of the lumen, so that the blood that is traveling through there, and you remember the blood is made up of a ton of different little things, right? It's not just red blood cells. It's red blood cells and proteins in the plasma, and white blood cells and all, what have you, right? We don't want them sticking to the inside of the wall. We want them to go nice and smoothly through the lumen, and that's what the endothelial cell endothelium really helps with. So what happens when we talked about in this very first step here, how there's damage to that endothelium. So what happens? When those cells are damaged, they can't make their normal amount of like antithrombolytic and vasodilating cytokines. And we've talked about, I'm not going to go over all of those because we've talked about them. But really, those things, those little, cytokines that are being released from the endothelium are not there. And so you're going to end up being much, much more susceptible to vasoconstriction. So that's one just kind of little thing that's happening with that damage. On top of it, we have damage, right, to those endothelial cells. So right away, your inflammatory response is going to kick in. That non-specific inflammatory response is going to release those cytokines like your tumor necrosis factor, interferons, interleukins, and don't worry, you don't need to have those memorized. Just understand that there's an inflammatory response happening there, right? One of the biggest things is that it releases these free radicals. And I drew kind of a little silly picture. This is not what a free radical actually looks like, but it helps me to kind of understand. A free radical is basically, if you think of it basically as a molecule that, if you remember back from OChem or I don't know, high school chemistry or whatever, we have these electrons, right, that are kind of circling an atom or circling. And when a free radical, just think of it, it basically has one less electron than it should. It has one unpaired electron. And all you need to remember from that is that when you have an unpaired electron like that, it's very, very likely that that molecule is going to react to other molecules. And that's exactly what happens. So we've got this damage to the endothelium, which has released all these cytokines, but also these free radicals. And those free radicals will actually come into play with low density lipoproteins, which are we'll talk about what they are a little bit, but that are already in your blood. Okay, they're already at the site. And basically what it does is it steals one of those electrons from that low density, or the LDL. It steals it. And what happens is now you've got this LDL that doesn't have its equal number of electrons, and now it's like unstable, right? And this whole process of, basically, this is how I think of it, as like of stealing electrons, is called oxidization. So when you see in your textbook or in your notes, like, oh, the free radicals are released and they oxidize LDL. And oftentimes that's all your textbook will say. And I find that, sure, you can memorize that if you want, but you can also try to have a basic understanding of what that means. We're not going, really, really deeply into, into the molecular structure of these substances or whatever, but just have an understanding. This is what's happening. It's oxidizing, meaning it's stealing an electron from the LDL and making it basically hyperreactive, which is it pretty much ends up being toxic. So let's talk about where those LDL have come from. So, you know what, actually, those LDL are already in your blood, right? We've talked about. So if you look here in this drawing, you can kind of see those, the yellow ones are representing the LDL floating around in your bloodstream. Those are basically cholesterol that your body has broken down into smaller lipoproteins in order to travel through your blood system, the blood flow. I'm going to talk a little bit more about it later, but just so you understand, like it's just little lipoproteins. The body uses these to help maintain and form like cellular membranes. So like those, they're useful. We need them. However, your body generally makes makes enough cholesterol for your use. So anything extra, so if you have a diet that's high in cholesterol, for example, you have that buildup of those lipo, the low density lipoproteins. This is a really, you can break this down and get really, really complicated, but you just need to know there's a buildup of LDL. So if you look here at these, this kind of process here, you've got that damage to the endothelium, which has caused a release of these free radicals. But you also have these LDLs that have been building up in your system. So you have too much LDL as it is. So now you've got all of these LDLs that are becoming oxidized. And yes, it's really important to remember that the oxidation of LDL is increased by those three big things we talked about in the last video: hypertension, diabetes, and smoking. These are always your top three kind of concerns when we're talking about coronary artery disease. Okay, so if you have any questions like that on exam, go with those three. The select all that apply, those three for sure. So once these kind of LDL have been oxidized, what they do is they kind of burrow down into that basement membrane. So you can kind of see down here, I tried to make it look like they were under there. So they're not in the muscle cell. They're not in the muscle cells yet, but they are kind of underneath the endothelium in that basement membrane. And that is where they will accumulate. Okay, that is where that basically that fatty streak is going to start. So we're still, if we scroll up here to what we went through one of those, we still haven't really reached this fatty streak stage. Everything we've talked about right now has been kind of between this injury and on its way to the fatty streak. So you've got these oxidized low density lipoproteins that have built up now in the subendothelial, so underneath the endothelium, and they accumulate there. As they accumulate, your inflammatory response increases. So you've already have some inflammatory response going on because of the damage to the endothelium, but now it's kind of kicked into high gear, and now we're going to have that recruitment of monocytes. You remember that that's the site of injury, right? You're going to have part of your inflammatory process is to have those phagocytes come and engulf whatever is there, whatever pathogen or debris or what have you is there. And that's what's happening. Your body's calling in these monocytes to come and engulf those oxidized LDLs because they're dangerous. And so if you look here, I kind of tried to kind of go through the phases so you can kind of see them visually. You've got these oxidized LDLs right here, right? And you've got these macrophages. And you remember that the macrophages come in the blood. They're monocytes. They come in the blood and they burrow into the endothelial layer, into the tissue. And once they get into the tissue, they turn into macrophages. And those macrophages engulf the toxic or oxidized LDL. Now, normally a phagocytic cell would break that down and there would be some debris and what have you. But in this case, once those macrophages engulf those oxidized LDL, they stay kind of in that form and they become what we call foam cells right here. So the foam cells are kind of a mixture of an oxidized LDL and your macrophages, right? And it's those foam cells that build up and form the fatty streak. Okay, so all of that, all of those kind of stages are happening between that original damage and that fatty streak. It's once those foam cells start to build up, they form that fatty streak. Okay, so that's kind of your, I guess, your second stage. Really, it's your phase, it's really your first phase of the actual atherosclerosis. None of this here that we've just talked about is atherosclerosis yet. It's just what's slowly causing the atherosclerosis. So there's some confusion about, like, phases in the atherosclerotic, like pathogenesis, and really that buildup of those foam cells, you can see it here. That's really your first phase of atherosclerosis. So before we go forward on that, I just want to talk a little bit about one of the other things that those foam cells will do, and that is as they're building up, they release even more inflammatory mediators. And what you have is this proliferation of smooth muscle cells. So this is, again, in that middle portion of the wall right here, where you've got all those smooth muscle cells. Those actually will begin to multiply at an abnormal rate, and it makes this part of the wall thicker, right? And when you have a thickening of muscle wall, it's just like what we talked about when we talked about left ventricular hypertrophy. When you have a thickening of that muscle, it's going to become less, kind of less elastic. It loses its ability to contract and dilate in response to the signals that are sent by the baroreceptors. And so it's part of this whole hardening, this, quote unquote, hardening of the arteries. I think that's kind of where that idea of the arteries themselves hardening came from, is this proliferation of the smooth muscle cells in the media. In the media. Okay, so it's done that. And sorry, my picture doesn't really show like a nice big, extra big middle layer. You just kind of have to imagine it. This will actually, so I found there was a little bit of confusion in terms of stages and phases and what's an atheroma and what's a fibrous plaque and so on. So I wanted to kind of put something together that broke all of those things down. So let's look at these three phases of atherosclerosis first. Again, we've got your fatty streak, which is just a buildup of those foam cells. Here we have this phase 2, which is basically your, if you look up here, it's that fibrous plaque stage right here. It's where your that collagen has started to grow up over and develop kind of a cap over top of this fibrous plaque to kind of settle it in. So you end up with this kind of lipid core underneath, and then this kind of fibrous collagen cap over top of it. That is your second phase. When that collagen grows up over that collagen cap, that is phase 2 of atherosclerosis. Phase 3 is basically when it becomes a complicated lesion, which we saw up here, when it becomes unstable. It may rupture, it may, quote unquote, grow a thrombus, but it really begins to occlude the artery quite severely at this point. Okay, so atherosclerosis in its own, you've got your phase 1 fatty streak, your phase 2 collagen cap, and your phase 3 complicated lesion. Sometimes they will, I find a lot of this kind of diagram floating around online, and I just wanted to kind of break it down. Because on top of those 3 stages or 3 phases of atherosclerosis, I don't know who set them up, but there are classifications of coronary lesions. And that's lesions in general. Doesn't necessarily only refer to a fatty streak or collagen, cap or anything. It's just any lesion in the coronary artery has, it's graded, right? And so right here, during phase 1, when you have that buildup of the foam cells and it has now a fatty streak, that would be considered a type 2 lesion when we under like the classifications of coronary lesions. Okay, so you kind of have two different things going on. You have your phases of atherosclerosis, and then you have these lesion grading systems. Okay, so don't get those things confused. And then again, if we go down here, this is just breaking that down a little bit more into a little bit more detail. Okay, so it's really just the same thing we just looked at. You've got your foam cells building up here. Sorry, they're actually down here. Let me draw that in the right place. You have now your fatty streak growing here, right? This here would be your stage 1, stage 2 lesion. Now, as it's getting to a definite, closer to a stage 2 lesion, you've got that fatty streak is rising up, it's growing. The smooth muscle cells under here are beginning to proliferate. And this picture is great because it actually does show those smooth muscles proliferating, smooth muscle cells, proliferating. Once we get to the place where that fibrous cap is formed, that is what we would call an atheroma, right? Again, this is just a growth, and athero, we've talked about what that means already, right? So really that's just, it's the same information, just presented a little bit differently. I just found it a little bit confusing looking through, and I wanted to clarify. So again, you've got those lesions, right? We talked about type 2 lesion, that fatty streak is a type 2 lesion. So when does it become a type 3 lesion? Right around here, where you have that raised, the fatty streak kind of raises and the smooth muscle cells begin to proliferate. And you end up with, that type 4 lesion once you actually have that fibrous cap. So the fibrous cap is indicating your second phase of atherosclerosis, right? It can also be called an atheroma at that point, and it is classified as a type 4 lesion. That's it. It's not as complicated as I think it sometimes looks at first glance. And then again, you have this fibrous plaque, which is just basically the atheroma is growing. The lesion is at this point, the lesion is stable. It's got this big lipid core. You can see the smooth muscle cells have proliferated. You've got this fibrous cap, but it hasn't necessarily, it's blocking quite a lot of the lumen, but it hasn't necessarily, ruptured or anything like that. It's stable like that. And then we get to that complicated lesion part, which is where, and you can kind of see it here, where either a thrombus grows, you may have some kind of hemorrhage, and or rupture at that point. So I know that kind of, it's a lot. It is a lot. But I think if you go through this video again, I'm not going to go through it all again, but it's broken down quite simply. I found that, so I was looking at the Lewis Heitkemper, I was looking at Porth Patho, and then online, and I found that the most confusing part was these stages. Like, they're calling it stage 1 here, they're calling it phase 1, and I just really just wanted to break that in case you have a question on an exam that's asking you, what's happening during phase 1 or what type of lesion would be during phase 1. That's really where this kind of what we just talked about will come into play. So again, they're separate things. This classification of coronary lesions is separate from the phases of atherosclerosis. Okay, so make sure you just kind of go over that before you go on to write your test or what have you. And then in the next video, we're going to talk a little bit about how that thrombus forms. So we're going to talk about the clotting cascade. So we'll see you in a bit. We'll talk about that then.